So now let's say we're given a function in standard form. And the function you get is 4x. The function they give you is 4y minus x is equal to 20. And you're trying to graph this line. So in order to graph it first, you should be able to solve for y. So how do we solve for y? We need to isolate y. So we need to get rid of the x. So we're gonna add x to both sides. Now remember, there's always an invisible line, a wall, through the equal sign. This negative x and the plus x, they cancel. So I have 4y equals, we cannot combine the 20 and the x because the 20 does not have a variable, so we just write it out. Now, if you're solving for y, we still have this little 4 in front, and the 4 and the y are being multiplied, so you need to make sure that we do the opposite of multiplication, which is division. But if you divide the first term, you have to divide all the other terms by 4 too. We like to keep everybody at the same place. Whatever you do to one, you do to the other one. These cancel. This is y. There's an imaginary 1 in front of that x, so this becomes 1/4 x. And here, 20 divided by 4 is 5. Now, I've already solved this. It's in slope-intercept. My slope is 1/4. Because it's a positive 4, remember, it's rise over run. A positive 1 means we go up 1, and that positive 4 means we go right 4. And then my y-intercept would be a positive 5, which again, we start at a 0,5. So if you were asked to graph this, we're gonna have to give ourselves a little bit more room on the positive y. We start at the y-intercept, 1, 2, 3, 4, 5. Our slope says up 1 and 4 to the right, so 4 is here. Now, something that you should keep in mind also is if you don't have room to go up 1, 4, you could do the opposite of both. So instead of going up, we could go down 1, and instead of going right, you could go left 4. So from here, I could go down 1 and left 4, but when you graph this, you realize, hey, guess what? I'm still on the same line, but you're allowed to perform the slope in 2 different forms, depending on which one is more adequate to the graph that you are given. Now, what happens if they ask you, hey, can you find the line perpendicular to this? When we're looking for the line perpendicular, remember the main thing that you have to focus on is your slope. And the slope you had was 1/4. But we've learned that perpendicular lines have the opposite reciprocal. So the reciprocal of this would be 4/1. The opposite would mean the opposite sign, which really means just a -4. So this will be the new slope that you would have to use. Now, as long as you have the opposite slope, you could have any number for your y-intercept. That line would be perpendicular to it. So I could just stay with +3. So if my slope is a -4/1, that means down 4 and right 1 because it's a +1, and my y-intercept would be 0, 3. So let's graph this line and let's see if they actually look perpendicular. And remember, perpendicular means that they're going to intersect and make a 90-degree angle. So we start off at the +3, and then it says we go down 4, 1, 2, 3, 4, and 1 to the right. So if, or like we did over here, we could go up 4 and left 1. 1, 2, 3, 4, and left 1. So if I were to draw this line, the question is, does it seem like they have that right angle right there? And they do. So this line and this line are lines that are perpendicular to each other, because once again, how do you find out that lines are perpendicular? Their slopes are going to be opposite reciprocals of each other, and that's exactly what we have here. So we went over standard form to slope-intercept, we sketched it, did the perpendicular line by getting the opposite reciprocal. We graphed them to prove that they actually make that 90-degree angle right there.